Hello everyone, welcome to today's video. We're going to be going over the communication script. This is already in my GitHub with some minor changes to the version you'll see here. And this is mostly to determine if we have a good enough link between the probes and the orbiter and the orbiter and the deep space network. So we have both UHF links down to the probes, one at 433 and the other at 915 megahertz, sorry. And then we're using the X-band to transmit to deep space network. We have 200 watts of RF power, and that's with an amp, so it's an all-frequency amp that we'll have in. So both the X-band and UHF on the orbiter can use it. And there'll also be pass-throughs, but I'll talk about that later. In a different video, I should say, when I further talk about the communication system. This is just a script to determine radio occultation. Radio occulation is basically the refraction due to atmosphere. So that occurs here on the Earth. If you've ever listened to like AM radio late at night, you may be able to hear, well, you will be able to hear the transmission of a station further away due to it bouncing off the ionosphere. So occultation is just when a body goes in front of another in astrophysics, and in this case, it means that due to occultation, you can actually receive a signal from behind a body due to the reflection. The other thing about that is you can determine using the bend radius, the atmosphere, like determine measurements. And so that'll be really useful because part of MAGPIE is collecting data at multiple points at the same time. And of course we have surface probes, and these surface probes will be re-entering the atmosphere, but we'll get very limited data during the re-entry phase. So also having occultation at the same time is super helpful. So that's something the script calculates. I won't go into the math. It's pretty short. It's basic dish size calculators and gains, and basic Mars occultation estimation. So we'll run it. And boom, here's all of our graphs. We have quite a few. So first are some occultation stuff. It's just the refractivity of the atmosphere, and this is at different altitudes. And using that, we can determine more from the atmosphere. I don't show that because it's being calculated the opposite way. I'm using the atmosphere to determine the refractivity, and also the bending angle. So that's the angle when we hit the atmosphere. At different altitudes, it'll change our bending angle. Okay, now let's talk about some dish size. I think I have a few of these, yeah. Quite a few. Okay, I think these matter less for me to explain. I think the easiest way to say is like, oh, by the way. So conjunction and opposition, that's just different orientations of where the Earth and the Moon are. Opposition is the furthest and conjunction is the closest. Then of course you have an average. And so we can find, using that, as the diameter of our antenna gets larger, shocker, our gain goes up. Here we have link margin, because we have to be above at least 15, I think, to get a good reading. And of course, gain isn't linear and everything like that, so they should be logarithmic graphs. I will probably move that over, but for now, it doesn't really matter, because it's easier to see. I think the current diameter is going to be about 1 meter, which, as you can see, gives us quite good gain. Okay. just as the link margin and uplink downlink difference between the probe and the orbiter. It's not perfect because it's just a lot of estimation. So this doesn't actually do the orbital calc yet. That will be done. One of my goals after the paper is submitted for this project, I want to create a library that all of this pulls from, so you can kind of just use simple functions to determine all of this and it all works together. So this is a case of that needing to be implemented. So I also have some printouts, and these are just basic data prints of our downlink margin, uplink margin, based on our known estimations. And we also can see that, so we, based on some other calculations that are done in Excel, the amount of data we need to transmit. And it's basically determining what should we have for, and it's just over a megabyte. It's not precise because I won't always be transmitting stills. And stills will likely be black and white for most of the time. But we still want to transmit images from all sites, and not all sites will have power forever. Which is hopefully next week's video if it isn't on CAD. But yeah, feel free to go to the description down below and look at my GitHub. It's in the code section. I will organize that better, but for now it's just the communications package. All right, thank you very much for watching. Have a good day. Bye bye.